Hello and welcome. In this video, we're going to be looking at another tough Edexcel question. This question is from the June 2018 paper. It looks like a kinematics question. Let's try to attempt it. So first, let's try to read the question. Question says, a cyclist starts from rest at point O on a horizontal road, straight horizontal road. The cyclist moves along the road with constant acceleration, which is 2 meters per second for 4 seconds, and then continues to move along the road at constant speed. At the instant when the cyclist stops accelerating, so what happens when the cyclist stops accelerating and starts moving at constant speed? At that instant, another motorcyclist starts from rest at the same point and moves along the road with constant acceleration of 4 meters per second. So now, the first cyclist was accelerating and then he started moving with a constant velocity. The second cyclist was accelerating, however, with a greater acceleration, so a steeper curve, and we're gonna talk about this. And he is going in the same direction, and probably what you expect is, since the motorcycle is never going to stop accelerating, it's gonna stay increasing in speed, at some point it's going to overtake the cyclist, right? So the motorcyclist has been moving for t seconds when she overtakes the cyclist. Sketch on the same axis a speed time graph for the motion of the cyclist and the speed time graph for the motion of the motorcyclist to the time when the motorcyclist overtakes the cyclist. Okay, lots of cycling here. So for part A, the first thing that you need to know is we're asked to draw a speed time graph. In a speed time graph, we know that speed is going to be on the y-axis, time is always on the x-axis. So this is time in second, this is speed in meter per second. Right. Some important characteristics that we need to know for a speed time graph are: one, that the gradient or the slope is basically y over x. Y is speed, x is time, speed over time is acceleration. So gradient is my acceleration. Okay. Second thing, area is similar to y times x. Y is speed, x is time. So speed times time, that is distance. These are the two most important things that you need to know, and I went through this thoroughly and with derivation and how to understand this fully in my course that I'm going to leave a link on the top right hand corner. Please feel free to check it out. It's a Udemy course. It's amazing. It's all you need to score a good mark in your mechanics test. So saying this, let's continue. Okay, so let's first start to draw the cyclist. Okay, so the cyclist, what happens? The cyclist starts from rest. Starts from rest, it means that it was at a speed of 0. You always think here about the speed. Speed was 0 meter per second at time t equals 0 meter per second. The cyclist was accelerating for with an acceleration of 2 meter per second squared for 4 seconds. Okay? So what I want to know here is, I'm sure that since this is a constant acceleration, my acceleration is constant, that means that my gradient is constant. My acceleration is 2, that means my gradient is 2. Okay, so a constant gradient looks like a straight line, right? So the cyclist is going to be moving with a straight line, something like this, let's say, up to a certain velocity, and then after that he's going to start moving at constant speed. Constant speed means what? So constant speed means, do I have any acceleration? No. So my acceleration is 0. So what tells me about the gradient? Gradient is also 0. And I know that the gradient is 0 when I have a horizontal line. So this is a horizontal line over here. Okay. Now, let's talk about this velocity over here. Which velocity is the cyclist going to reach? So from Saviot, if you know Saviot, these constant acceleration equations, the first one, which is v equals u plus at, is going to help me. Why? Because I have my u is 0. I have my acceleration, which is 2 meters per second. I have my time, which is 4 seconds, and I want my v. So v is going to equal u, which is 0, plus acceleration, which was 2, times time, which is 4. So my velocity is going to be 2 times 4, which is 8 meters per second. So at this point over here, the time that has passed is 4 seconds, and the velocity is 8 meters per second. And now we've finished fully what we want to talk about regarding the cyclist. Okay? Now let's do the one that's a little bit more complicated, the motorcyclist. So what happens? At the instant when the cyclist stops accelerating, when is this instant? Is at t equals 4. So at this instant, so after 4 seconds, what happens? Now, let's draw it with another color actually. So at 4 seconds, what happened? The motorcyclist starts from rest. Again, rest means that my velocity, the y-axis, is going to be 0. So I'm going to start from 0. And moves along the road with constant acceleration 4 meters per second. I can see that the acceleration here is double the acceleration here. Is the green line acceleration is double the red line acceleration. So the gradient should also be double. So I will expect it to be a little bit more steeper, or double the steepness, something like this. Yeah? It's gonna keep on accelerating. Does it tell me anything else? No, it's just accelerating. The motorcycle has been moving for t seconds when she overtakes the cyclist. Okay, this is super important. Overtakes means what? Overtakes means what? Let's say this is my starting line. Okay, both of them start here. This moves over here. Okay, like let's say it moves 20. This is 20 meters. So it moves 20 meters. Now it's here. Okay, the other one, when does it overtake? Does it overtake when they reach the same speed? No, because this could be moving at 8 meters per second here. Okay, and this over here also at 8 meters per second, but maybe it started a little late. So the velocity doesn't dictate when we overtake. What is the thing that dictates when do we overtake? The only thing that dictates when do we overtake is the actual distance. So when this second particle is at 20 meters as well as the first particle, that's when I can say that it overtook it. It's now winning it if it's a race. You get me? So what dictates is the distance, right? So when their distances are equal, that's how I know that they're exactly at the same point. Let's apply that thing over here. So we said that the motorcyclist has been moving for t seconds when she overtakes the cyclist. So starting from the motorcycle, it moved t seconds. So it moved t seconds, yeah, until it overtook the cyclist. So let's say the point of overtaking, let's say, is over here. Let's say this point. Okay. So this distance is t seconds, right? This interval is t seconds. So this means that at my axis, this is 4 plus right? And at this instant, they overtook each other. How do I know that they overtook? Again, we talked about the distance. We dictate how or whether they overtook each other or no using the distance. And what's the distance in a speed time graph? It's the area. So they overtook each other when the distances they moved are the same, which means that the overtaking happens when the areas under each graph is the same. So basically when this area, okay, is the same as this area over here. Yeah, this is the point where overtaking happens. So now let's try to get that point by applying the areas concept that we just talked about. So let's remove this, we don't need it. So let's call the cyclist area 1. Okay, and I can see that this area looks like a trapezium area, right? It looks like a trapezium, correct? So the area of a trapezium is basically base 1. Base 1 is this whole thing, which is 4 plus t, plus base 2, which is this part over here, and we said that this interval is t, or if you want, you can do 4 plus t minus 4. That's also going to give you t, so plus t. So the first the base 1 plus base 2 over 2 multiply the height of the trapezium. So this height over here, and I can see that this height is basically 8 meters per second. So this is the first area. Like the second area, I can see that it's an area of a triangle. This area over here is the area of a triangle. This area. This looks like a triangle. Yeah. So it's half base times height. Base is this, so the base is also t. However, I don't have what is the height, and I need to work on it. So let's see how we can get the height first before we start getting our area. So we know again from for the motorcyclist, what do we know about it? We know that it started from rest. The acceleration was 4 meters per second. Yeah, and the time interval that we are interested in, the time it moved until our interest point, is basically time t. So the time it took is time t, and I want to find the height, which is the final velocity it reached, right? So I have u, a, t, and v. I didn't mention s, I didn't mention the displacement or the distance, so I'm going to use this equation, which is v equals u plus a t. So v is going to equal u, which is 0, plus 4 times t, which is the big T that we know. So my velocity is 4 times t. So actually this point over here has a value of 4t. So let's use that to find the area of the triangle. So area 2 is going to equal half times base, which is this interval, so times t, times the height, which is all of this height, the height of the triangle, which is basically 4t. So times 4t. So this is equal to half times 4 is 2, t times t is t squared. So over here, let's simplify this one. Let's, we don't need this, let's remove it. And by the way, I've done a full playlist on mechanics hard questions. I'm going to leave it in the top right hand corner. Feel free to check it out. So let's simplify area 1. Area 1 is going to be, okay, 2 and 8, this can simplify into 4. And then t plus t is 2t. And then I have a plus 4. So multiplying the 4 inside, this is going to equal 8t plus 16. So that is area 1. And area 2 is 2t squared. So when I equate them to each other, that should give me the time where the overtaking happens, because we said overtaking happens when the areas are equal. So over here, I can move everything to one side. So I'm going to have 2t squared. I'm going to move this 8t to the other side, minus 8t minus 16 equals 0. And I can see that this is a quadratic. And by the way, I've done also a full playlist on quadratics. I'm going to leave it on the top right hand corner. Feel free to check it out. So I'm going to solve using the quadratic formula, which goes like this: minus b plus or minus square root of b squared minus 4ac over 2a. This is a, this is b, and this is c. So it's going to equal minus b, so minus negative 8, that is 8, plus or minus square root of b squared, so negative 8 squared, minus 4, multiply a, which is 2, multiply c, which is negative 16, then everything over 2a, which is going to be 2 times 2. Putting this on the calculator, one time putting this sign as plus, another time putting this sign as minus, is going to give me 2 answers. The first answer is going to be t equals 5.5 seconds. That's the first answer. The second answer is going to be when t equals, so when I change this to minus, is going to give me an answer of negative 1.46 seconds. That is wrong because time can never be negative, so I'm going to neglect this, and my answer is going to be 5.5 seconds. And this is the time where the motorcyclist overtakes the cyclist. This is a short question when you know what to do. However, it could be super tricky if you're attempting it for the first time. So what I would suggest is you try to repeat the video or solve it on your own, and see which part you feel like you're stuck on, and then continue with the video to help you. Please leave your comments and suggestions down below. Don't forget to like, subscribe, and comment. I'll see you next time. Thank you for watching.